My project title is Changing Flower Color. Purpose: I am researching which color will change its flower fastest. Hypothesis: my hypotheses are the darker the watercolor is, the faster the flower will change color. The shorter the stem is, the faster its flower will change color. Research: all plants need water to survive. The leaves and petals of plants have lots of tiny holes called stomachs. Water travels up the stem and spreads to leaves and petals. Materials: 3 clear glass cups, water, 3 food coloring colors, red, blue, red, and yellow. Non-white flowers, including 3 same kind and same long stems, 3 same kind and medium stems, and 3 same kind and short stems white flowers. Experiment. First, I filled 3 glass cups with water. Next, I put 10 drops of each food coloring color, blue, red, and yellow into each glass cup. First experiment. I prepared 3 same kind and long white flowers. Then I put 1 flower in each cup. I observed on a chart for 10 days for the changing color progress. Over here I have a first experiment observing chart. And a red flower, a blue flower, yellow flower, and the flowers of experiment 1. Second experiment. I prepared the 6 same kind white flowers. I cut 3 flowers same length and the other 3 shorter length. Then I put 1 short and 1 long stem flower into each colored water glass cup. I observed on the chart for 10 days for the changing color progress. I was second experiment observing chart, and a red short and a red medium, and a blue short and a blue medium, and a yellow short and a yellow medium, and the flowers of second experiment. Analysis. On my first experiment, the first flower changed its color was the blue water glass flower. Then the next ones are yellow, and red. On my second experiment, after observing for 10 days, all 3 short stems of white flowers started to change their flower color on the first day. The rest of the 3 longer stems of the white flowers started to change their flower color after a couple days later. Conclusion. My hypotheses were right for both experiments. The darker the watercolor is, the faster its flower will change. The shorter the flower is, the faster it will change. Water travels up the stem of each flower and spreads to the rest of the parts in the flower, including petals. Water is evaporated through stomachs. When the water gets evaporated, the flower then needs new water so it can grow and change. How did you know how much color went into the water?
Did you count how many drops of food coloring you put?
10 drops. Eating. Why did you experiment with big, medium, and small, instead of only one? Because I used that for the second experiment hypothesis. The shorter the stem is, the faster its flower will change color.
What kind of flowers did you use?
White flowers.
Do you know what the names were? Okay. All right. Thank you, Ivan. You can just set it right over there. That's fine. All right. Next person up is Anish.
So my scientific name
Wait, let me peek you. Wait, peek you. All right.
So my,
Hold on 1 second, Anish. Thank you so much for
I'm
being
getting impatient.
I know. So enthusiastic. 1 second. I want the camera to see every part of it. Okay. The question, though. What's your purpose? Okay.
So my scientific name is like the size of a magnet affects its power. Recently in school we had done about magnet electricity and I wanted to do a science project about either one. Electricity is too dangerous for us to do in school, so I decided to do it on magnetism. My hypothesis is I think a bigger magnet attracts more objects from far distance than a smaller magnet. Materials I used were 4 types of magnets. All of them were ceramic. 2 of them were rectangular and 2 of them were circular. We had named the magnets R1, R2, C1, and C2. The chart over here shows how big each magnet was. And here's the clip I used, here's the ruler, and here are the magnets itself. So what I had to do for preparation is I assembled my workstation. It was basically 2 pieces of paper. I placed my ruler on one and the clip at 10 centimeters, and I put this magnet at 0 centimeters. And I started moving the clip closer until it was attracted to the magnet, and I measured the distance. I did that same experiment with all 4 of these magnets, and then I thought, how about I start combining magnets, and I wrote all my observations in this chart over here. So here you can see that 1 can attract the clip from 1.5 centimeters away, but 2 can attract from 3 centimeters away, but 1 or 2 can attract from 1.5 again, but 2 or 2 can also attract it from 2. So I found out that 2 bigger magnets can attract from more distance away than 2 smaller magnets. There were 6 C1s and there were 8 C2s. On 5 to 6 C2s, it only stays at 3 centimeters. I thought this was happening because I was stacking them on top, and I thought the magnetic wave was going over the clip, and if the clip was dangling in midair, we'd be able to attract to the magnet. But on 7 to 8 C2, it was only at 0.1, and I have no idea how that was happening. And then I took 1 magnet out of each type, and then I stacked them, and it can attract the clip from 4.3 centimeters away, but all 18 magnets can attract it from 5.5 centimeters away. My conclusion was my hypothesis was correct. Small magnets hold an elastic for a small distance than bigger magnets. I also found out that combining many magnets increased the attracting force, but all the magnets has the most attracting force. And done. Any questions?
How many centimeters was the large magnet?
Which one?
How many, like,
Which magnet?
R1?
How many centimeters away? 1.5.
No, how many centimeters long?
Oh, the width of the ones. The length was 2 inches, same as R2, but R2 was only 0.006. This is Russia.
Did you buy them, or did your parents buy them?
I went with my parents. Okay.
Thank you, Anish.
Why should I do this?
You know, just right. Oh, right. I gotta choose you first. Are you two okay?
Yeah, they're fine. They didn't drop on me.
Closer to here. All right, Cosme, you are next.
title of my project is Color Preferences. My question is, do pets see colors? If they do, can we test their color preferences? Purpose. My purpose is to determine whether the color of the container that contains the food influences a pet's eating habits. My hypothesis is that pets are attracted to light colors like yellow and red. Materials: fish, metal, rubber bands, half-inch diameter, blue, black, green, and red. Fish food and notebook. Procedure. 1. Place the colored ring on the water surface right above the fish. 2. Place an equal amount of food and 2 bits of dried fish food in the colored ring. 3. Start the timer. 4. Whenever the fish eats from one of the rings, write down the color of the ring and the seconds from the beginning of the experiment. 5. Compare time to eat the food in the ring. Repeat this. 6. Repeat this every day. My data is, the date is on the side here, the average, there's red, green, blue, and black. These are the seconds from the beginning of the experiment, and these are the average. Concluding, my pet seems to be attracted to dark shades, like black and dark blue. For further experiments, test this conclusion with other betta fish. Explore why this betta fish doesn't like red, as you can see up here. Any questions? Any? Why didn't it like the red? I do not know. Anish? Or did you have to set the timer? So that I know how many seconds from the beginning of the experiment. Okay. So no. What would happen if you used a different type of fish but still a fish? I don't know. Marsha? Did you use wiggling? Huh? Did you use wiggling? No. Mr. Faber?
They eat from like their favorite ring and then they eat the other food too, or did they just eat from one ring and then we're done?
They ate first. So first they ate from black because it's the lower seconds from the beginning.
Got it. Okay, but they did eat when you put them in. They would eat all the food. It was just
Sometimes, but they never ate red.
never ate red. Interesting.
Alicia's dad.
Did all the fish eat from the same color, or did different fishes go to different colors?
There's one fish.
Just there's only one fish.
Oh, yeah. That's a good question.
What was the name of the fish?
Magneto.
Oh, good deal.
Good job.
Good job.
Okay. Ayana, you're going next.
Hello, my name is Ayana, and today I'll be presenting my science experiment. Science experiment's name is Different Plant Liquid. My hypothesis is I think water will go the best. My purpose for question is which liquid will make which plant go the fastest. My materials are soil, 5 liquids of your choice, 5 pots, straws to hold up the vines if they fall over, and labels. My experiment is first vial of materials, next put soil in the pots, then put seeds in the pots. After that put more soil, then water the plants once after 2 days, and once they grow nice and tall, if they fall over, put straws to hold them up. Over here, here's my first picture. As you can see, there's no growth. My second picture, as you can see, there's still no growth. And then my third picture, I'm holding up a graph, and there's just a little bit growth. Now, my last picture, it shows nice and tall like now. My first graph shows sprout count over time. The light brown represents how many sprouts in week 3. The dark brown represents how many sprouts in week 4. With the most sprouts, coffee has 38 sprouts. And with the least sprouts, milk and soda tide hold 11 sprouts. My next graph is plant height over time. The light green represents how many inches in week 3. The dark green represents how many inches in week 4. With the most sprouts, coffee and water tide with both 14 sprouts. Well, actually 14 inches tall. Fruit juice